one last administrative reminder is that you guys, two things. The number one thing is if anybody didn't have his t-shirt or bag or cup or sticker or whatever, just go there, they have it for you. If you, I mean, you've understood, right, why I made the stickers, right? They are the exact size to put there in this trademarked logo. Because the logo looks way better with the objectives logo. Number two is reminding you about tomorrow evening for those who stay in town tomorrow evening and want to join us at the very cool Spanish restaurant, which by the way wasn't my short list for this evening, but the other guys went. I need a number. I need to know how many people are going to come with us. I'm going to call those people at 5 p.m. today and tell them tomorrow evening we come with whatever, 20, 30, 40, 50. And they will make room for us and prepare some delicious meat. I ate in this Spanish restaurant a couple of weeks ago. It's pretty cool. Alright, let's go to the next one. After my German teacher, here's my retained release teacher. And there's actually an explanation for that. When I saw it, working with Objective-C and Coco, actually when I teach it, a lot of my students ask me, how did you start it? And I tell them, I'm going to tell you my secret weapon. My secret weapon is not especially Xcode. My secret weapon is my #bed list. Because I have so many friends over there thanks to the things I did with the podcast and anything. But it doesn't matter what it is, I can always ask some guy like Ken, like Altwin, because there is always somebody awake, which is cool. And Ken helped me a lot. And a lot of time I would ask him a question, then he would just come back and say, dude, this is basic C. And I would be like, dude, I'm a .NET developer. So basic C doesn't mean anything for me. So I had to learn a lot of C things. And then he would go with things like, well, it's pretty straightforward. Yeah, right, but for you, not for a .NET developer. And then he would go with things like, but all you have to do is blah, 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 and I would end up in some kind of hexadecimal thingy. Or error code, or whatever, or assembler. So, the other thing, which is pretty awesome with Ken, and by the way, his brother as well, is that Xcode 4? No way. They used Xcode 3 up until recently, and they were happy about them, and I hated them for that because I couldn't keep on using Xcode 3, so I had to use Xcode Crash. And those are all of mine. The last one, though, is from any of the two, Ken or Glenn. I think it was from Ken. At one point, I told them, you know, your website, it could be better. And said, nah, we're so Web 1.0. I was like, that's true. Anyway, it might be Web 1.0, but although he's going to teach you how to debug code, I think he doesn't have any bug in his code. Let's welcome Ken Aspeslagh, as it's supposed to be pronounced.
Thank you, Stuff, for the introduction. That was really nice. That was fun. Good picture. And I just want to say thanks to Mike and Orwin for their great talks so far. Another technical talk coming up, but I'm going to try to keep it interesting. Just to introduce myself, I am half of Ecamm Network. We do Mac apps, but I'm going to try to keep what I'm saying relevant to Mac and iOS, because I know you guys do a lot of iPhone. We've dabbled in it. We've stayed with the Mac stuff. Fortunately, most of the development is the same. The only real difference is the UI. So I think this should be relevant to you guys. So I got some quotes in here. There's Kernighan. I don't know if you guys have heard this quote before, but I love it because it's just this logical conundrum that if you wrote difficult code, no one's ever going to be able to debug it, and he lays it out so clearly. Now, the first step to debugging, if you have bugs, which Stuff pointed out we don't, but in theory if you had bugs, the first step is to reproduce. Oh, not that kind of reproduce.
I'm good at it.
I'm just going to take a minute to thank Stuff for organizing this, because we go way back. This guy who brought us all here today, he follows his dreams with a passion like I've never seen anybody else do before. I've known him since, I don't know, 7 or 8 years now. And when I first met him, he was a podcaster, .NET programmer. And then one day he woke up and he said, I'm going to be an iOS programmer. And you know how you knew? He changed his iChat status to iOS programmer. And he left it that way for 2 years. And because when he just commits himself to something, he does it. When he said, I'm going to hold a conference, you knew he was going to hold a conference. It was going to be epic. And then this is the result. And this is just he's one, he's here's Yosemite again. He's one of the crazy ones from that commercial that Mike played. I mean, you can't ignore him. He pushes the world forward, and he's the kind of guy who changes the world. And where would we be today if he hadn't done this? We'd probably be at home. So, getting back to the... oh yeah, and this is his baby, but that's his other baby that he planned right at the same time as the conference was happening. So, like I was saying, the first step is not actually to reproduce. Now, the first step is gathering data. You could be, if this is a bug from a customer, you need to know what's going on. So you need to gather data, you need to gather logs, you need to gather crash reports, crucial information, OS version, the version of your app that they're using. These are things that you need to gather. You should have methods in place for getting this information. No one can send us a customer support request without filling out the field that says what OS X version they're on and what version of the app they're on. A lot of people get lazy, they just write current or latest, which is usually bullshit. They're usually running some old version, and that's the problem. Then you need to reproduce the bug. If you can't reproduce the bug, you can't fix the bug. Or else you're doing something called shotgun debugging, which is kind of worse than shooting and stabbing in the dark. It's more like archery in the dark, because you don't even know if you're hitting anything. You don't know if what you're doing is fixing the problem. You're just changing bits of your code. You're and hoping it gets fixed. It's not going to work. It almost never works. And then a lot of times you need to simplify your code down. When you file a bug to Apple, they'll often ask for a simple project that reproduces the problem. You don't always have to do this. You don't necessarily need to build this little test case, but as far as simplifying, a lot of times it means if you've got a random crasher, the dreaded random crasher where you don't even know which code is causing it, a lot of times I'll tell somebody, they'll come to me on iChat buddy list, and they'll say, I don't know what's causing the crash. Well, can you comment out half your code, see if it still happens? And if it does, comment out the other half of your code. I mean, literally, and you're literally binary searching your way through your code until the bug disappears. And you locate the cause. Now, I've got another quote here. I don't know if this is still true. I don't know when he said this. But we can take the meaning from this quote to be that you should still have a lot of logging in your app. There's nothing wrong with printfs. Some people consider it caveman debugging, but as you code, you should be building these log statements into your code. They should be in there from day one. As you code the beginning of your scramble this sort routine function, you should be adding prints as you go. Don't try to add them later when the problem occurs. Just add logging as you're going. It should be built into the program. Can I use this too? I'm going to use this. So there are two main situations when you're debugging an app. Situation one is the app is in development. These log statements are very crucial when you're figuring out what's going on. Situation two, you're working with the customer in the field, and you need to know what they're doing. Getting that log back from them can show you exactly the flow through your program. Along with the crash report, the log can show you exactly what they did. If you put in logging that actually matters. I had one get a log from a customer the other day. And when the log came back, I realized to my embarrassment that there was nothing in the log at all about the problem they were having. And we just put them through the process of getting us a log for nothing. So we use our own routines these are just simple drop-in interfaces for Aspeslagh and printf that are conditionally turned on and offable. So in a debug build, they're always on. In a deployment build, they only happen if the user checks a hidden checkbox. So basically, this is the preferences from an app of ours. And if you hold down the Option key when you're going into the preferences, that new checkbox appears. The user clicks it, and now the log files are getting generated. We have people do this all the time. It saves so much time. And we just say, turn on logging. And you could consider even putting some automatic way for them to send you the logs, because a lot of users don't know about attachments. This doesn't necessarily apply to iOS as much, but you certainly could build a debug log into your app. And in this case, you would need an automatic way for them to send you the logs, because you couldn't just have them drag the file into email. You'd need a button, send me your logs. And if you could even send crash reports on the Mac automatically, or even the last little bit of a console, your code could get creative. You should be, like I said, adding this blogging as you code, and messages like, hey, I'm at the beginning of this function, and hey, I'm at the end of this function, are cool, because then you know whether you crash in the middle of that function, if you don't get to the end. At the beginning of the app, we usually try to print out into the log the version that's running. These are all amazing things to have later when you're looking through your logs. Hey, I'm running this app version 2.8.9. The OS is this. It's running in 32-bit mode, like I showed here. You just want to be printing this stuff out. Aside from logging, you could have a whole special debug window that the user could bring up, or the developer could bring up. Apple does this a lot. There's debug menus and hidden debug windows in almost every Apple app. There's a debug menu, and I'll probably use the developer menu in Safari, but there's also a debug menu in Photo Booth. There's a debug menu everywhere. And like I said, you can make your own diagnostic tool. You can make a separate app that gathers up logs, gathers up statistics, and sends it to you. And automatic crash reporting is something we recently started using. If you guys have looked at some of the stuff that's available, this is a screenshot of Hockey app that we recently set up in one of our apps. It's an automatic crash reporter. It's basically coalescing and symbolicating your crash reports in a much nicer way than Apple does. And then Glenn obsesses over them and tries to get them to go away. They never completely go away, but it's a good place to start. There's another quote. An interactive debugger is an outstanding example of what is not needed. It encourages trial and error hacking rather than systematic design, and also hides marginal people barely qualified for precision programming. I don't know when he said this either. I mean, maybe they weren't that good yet. But he's basically suggesting you should just never be using an interactive debugger. I don't know about that. The Xcode Debugger gives you some pretty cool abilities. But a lot of people often, especially beginner programmers, don't think to use the debugger. I've seen questions online like, oh, I'll press the button and the routine is not getting called. And it's like, you look in the debugger, like your outlet's probably nil. You probably forgot to drag the line. They never thought to go in there and look in the debugger. Just look at what's in the variable. But there's a lot of more powerful stuff you can do in there. You can view a section of memory. I'll talk a little bit about breakpoint actions and conditional breakpoints. And you need these kind of things when you're debugging a program that that you can't just set a breakpoint in. Like if you're debugging like a video app or a real-time kind of app, you can't just drop into the debugger to a breakpoint. If you're debugging Skype, say you're a Skype developer, you're debugging a Skype conference, and a breakpoint gets hit, the conference is going to get timed out and go away. You know, you're not going to be able to sit there and step through your variables and watch what happens. You have to have the ability to set breakpoints that don't stop the execution of the program, but can maybe execute a little script, print something to the console in a conditional way. So I took some screenshots of what this looks like if you've never used the smart breakpoints in Xcode before. The GUI changed from Xcode 3, but the same functionality is there. What you're doing is basically you can set a condition on a breakpoint, you can set what happens when the breakpoint gets hit, and then that last checkbox there at the bottom is what I was talking about in Xcode. So they actually don't stop at this breakpoint. Don't just do my action and keep going. And in that action box, you can put a GDB command or an LLDB command to like print out the contents of a variable or even call a function. So like in this case, if you can see that there, PO is actually maybe the value you want to print is in a variable. You can just call a routine to get the variable. Now, we're not all going to become GDB or LLDB, like command line experts in this talk. Our beards aren't long enough, or in Jason Harris's case, pointy enough. They're just not like, that's not going to happen. But that isn't to say you shouldn't be discouraged from learning some basic GDB commands. LLDB commands, the new debugger, they're very similar. They're not exactly the same. But if you don't know either one, it's a good time to get in there and learn some LLDB commands. Print PO is going to print the description of an Objective-C object. BT is just backtrace, it's going to show you your stack. All the routines up to the function you called. B is for setting a breakpoint in GDB. Continue will return from the routine you're in. All really useful things to have. There are a lot of other useful commands you can use. I'm not going to go through them, but if you just Google like LLDB cheat sheet or something, you'll find all the useful commands right there. So outside of the interactive debugger, it gets more interesting to me anyway. There are a lot of other tools on the system that you can use to debug that's not the debugger. For example, activity monitor. And you're all thinking, activity monitor? Why would that possibly be useful? But we're constantly using activity monitor to debug something like a hung process. If you're not in the debugger and you can't just hit pause, you just fire up activity monitor. There's a button there to sample a process. And it shows you the stack trace of every thread. And online, I guess, I don't know when they added it, it actually shows you the binary image dump like in a crash report. So you can see if there's any third-party plugins loaded, what other crap is on their system. We use that all the time now. Or if your app's sitting there and it's not being used, you look at activity monitor and say, why am I using 5% of the CPU? That's not cool. You just hit sample, you see what stuff your app is doing that it shouldn't be. And you look in there, you make sure you see what you expect and you don't see any nonsense. Because the user's going to complain if you're idle and you're using CPU. They're going to complain loudly. Again, those are mostly Mac-related suggestions. But instruments is a tool you can use on iOS as well. I am always in allocations instrument. A lot of people would think, what is it useful for? Obviously, tracking down memory leaks. But also just to optimize memory usage. Optimizations are really slow. They would take up most of the time in your program. Allocations, rather, are really slow. And a lot of times you'll notice you're doing something twice, 3 times, 4 times. It only needs to be done once. And I'm just going to do a little demo here of. Actually, I'll just show the slides here. No, I'll show the demo. I'll try to show the demo. But I think I can throw Xcode up on the screen here pretty easily. So say you have a project, and it's got a memory leak. So let's profile this app, and I'll show you how to find the memory leak. Instead of spending all day just hunting through your code for the leak, simply go up to the product menu and select Profile. The Instruments app will load right up. Select Allocations tool and press Profile. This app that I'm showing here is an app that we sell that recovers deleted files from a memory card, like if you delete all the pictures on your camera. So I'm going to hit Scan and start the process. You can see in the back this timeline is showing the memory that the app is using. And every time it finds a picture, it uses a little bit more memory. And that this isn't really very good at all. You can see the leak visually here in the timeline. So I'm just going to stop the scan. I'm going to come back into Instruments and actually pause the profiling. Now to find out where the memory is leaking, it's actually usually pretty easy. I'm just going to hold down the Option key and drag on the timeline to actually select a portion that I want to examine more closely. I'm just going to select one of those little spikes. Now down here in the object summary, I'm going to sort by the size of the allocations, because that usually shows you the most important ones first. And I'm just going to look at this top one. See, it's leaking about 1 megabyte each time. It's a CF data. I'm going to press on this little arrow next to CF data. That's going to bring me into the more detail section. Now I'm going to bring open the right pane here with this button up on the toolbar. And what you're going to see is a stack trace of when that allocation was made. If you scroll down and look for a line that's highlighted in black, that's your code. I'm just going to click on that line, and then I'm going to click on the Xcode button here, and it's going to bring me to that spot in my file and show me the area of the code where the leak is. Now this can really narrow down your search. It shouldn't take long after looking at this section of the code to find the problem. I can see it already. I'm doing an alloc here, and I'm not auto-releasing it. And then you just iterate that process. I'll do another profile. Launch back into the app. Start a new scan. And we can see that that large leak is gone. But there still seems to be a little bit of a leak. So then you would just repeat that same process. I'll show it again. I'll pause the scan, and then I'll use the Option key to drag a section of the timeline where the memory is increasing. Sort by the size of the leak. Go into the details, and it will show you the section of your code where the allocation is happening. I'm going to double click on the line of my code and press the Xcode button. And after a few moments, it takes you directly to the section of the code that's leaking. After a few minutes, you can usually see that your mistake, I need to move this auto-release pool on this thread into the loop. And then you would just iterate that process until all of your leaks are gone and that memory graph stays flat, or as flat as you'd expect it to stay. Go back to the slides here and go by these screenshots of what I showed you. Alright, so again, sanity check is also another reason to use that. If you're seeing huge amounts of memory being allocated, you should try to figure out why. And that brings me to the next section of the talk, which is reverse engineering. This is something we do heavily at my company. to get our apps to work. And most of the things I just showed are important tools. People ask, how do you do this? How do you do this reverse engineering? Most of the stuff I just showed you are what we do. And why would you want to be doing this? Interoperability with proprietary software. You know, you're not trying to steal the software you're reverse engineering's purpose. You're trying to make your software work with it. You're not like, I want to reverse engineer Skype so I can make a video conference program. That's not cool. You want to reverse engineer Skype so you can like add on to Skype? Totally allowed. And otherwise, to learn how things are done. For example, let's say you see Apple doing some cool thing, like when you buy an app on the App Store now and it like zooms down into the dock, you're like, how'd they do that? You know, you could sit there for a while, you could try to figure that out. How cool would it be to have that in your app? That's why you might want to get in there. And basically, the debugger, sample trace, allocations, breakpoints, the stuff I just showed are really useful in that. So, for example, maybe you're making your own activity monitor kind of app. How does the activity monitor work? So instead of stumbling around Googling how do I make an activity monitor, you just open up Activity Monitor and then use Activity Monitor to do a sample trace on Activity Monitor and press the sample process button. It's actually going to show a sample trace of all the things that are happening in the process. And then you'll just scan through that list. The main thread is going to be all of the UI calls, but as you get further down you can find the interesting threads. And here's a thread that's spending most of its time reading from a file handle. And I don't see anything else except UI. So what's going on here? You know, an experienced programmer would realize that it must be talking to a helper process over this file handle. If we go back to Activity Monitor, you can in fact find that there is a helper process called Activity Monitor D that is doing the actual work. You could then sample that process, and you would then find the actual calls that it was making to monitor the activity of processes. You'd probably find some kernel calls like host info, which you could then research and determine how Apple is monitoring activity. So just a good place to start, to just get a quick idea, how are they doing it? This shows you the routines. I mean, the actual app calls themselves might not be symbolicated, but any system APIs it's calling into are going to be right there. It's probably calling host info and kernel routines like that. But if you didn't know that, that would be really useful. And you can use that in any situation. Another example, just taken from daily life that I ran into was, say you have a Cocoa API. You don't really know what it's doing. It's like kind of a mysterious command. NS thread priority set thread priority. It takes a number from 0 to 1. But what does it mean? The API, the documentation doesn't really tell you. If you go and look at the low-level mock thread routines, they're much more complicated than this. There's all these different thread policies, and each policy has its own set of arguments. You know, what is this doing? If you look here, you can see this is the mock routine for setting up thread priority. It takes a thread priority policy flavor, and each flavor has its own struct of arguments. So why don't we just take an app, call that Cocoa routine, and set a breakpoint on thread policies, a breakpoint on thread policy set, and see what's being passed in, right? Is it that easy? Well, it's not going to be that easy because you're not going to have variables, you're not going to really be able to see like the arguments to the thread policy set very easily. But just to show you, oh, I didn't actually put this project on here. You're spared the Xcode, but basically, when you hit that breakpoint on thread policy set, the arguments to the routine are going to be in registers. So now, while it's unusual to really need to know about registers nowadays, it's still useful to have like a really basic understanding of what's going on. And now is like the best time to learn, because with 64-bit on the Mac anyway, and ARM on the iPhone, I think on ARM. Someone can correct me if I'm wrong, but the parameters to routines are all getting passed in registers. It's a pain in the butt on regular on 32-bit. But you just hit your breakpoint, you spin down. Actually, I've got a screenshot. You spin down in the variable area, that little register one you probably never come down, and you can see RCX there is variable is the first argument for the routine is 1, and 1 is red standard policy. So that wasn't very interesting. Just setting it to standard. So then you run again, you find out it's set red priority is calling red policy set again. This time it's calling it with 3 for the policy, which is precedence policy. And then if you want, to figure out what the priority is passing, and you look at another register and to find out the importance value. And this is where you need a little bit of GDB, because it's actually an into the register. And so that command there, the action, is going to be printing out the dereferencing RDX and printing out the value. And then what you'll find out when you run it is that it's mapping that 0 to 1 to like negative 31 to 31. You basically find out what's going on behind the scenes. Or say you wanted to figure out what Apple's doing in other apps with red policies, you can just investigate. In iChat, when you do a video conference, what red priorities is it using? How is Apple using these red priorities? Stuff like that. Fun with breakpoint actions. What would happen if you ran one of Apple's apps in the debugger and you just set a breakpoint on user defaults object for key and CF preferences copy app value and printed out the preference they were getting? Wouldn't it be kind of neat to see all the preferences they're accessing? I think we have enough time to just do this here. So, watch how quick this is. You're going to make fun of me for doing coding from a new project in a demo, but let's just make a new project. We're going to make a bundle. We're not actually going to have any code in it. We're just going to call it tasks. Save it to the desktop. And I'm going to come into the breakpoint window and set a breakpoint on CF preferences copy app value. I'll set a breakpoint action to, when I hit this routine, to print out RDI register, which is where the name of the preference is going to be, and continue after hitting it. And I repeat that process for NS user defaults object for key, except this time I'm going to print out RDX because that's where the name of the preference will be for this routine. This is the third argument. And continue. Going to go up to product and edit my scheme so that the executable that I'm running is a different app. Let's choose Photo Booth. I'm going to reveal the console here. And run. Now the system will launch Photo Booth, and you can see these preferences scrolling down the screen really fast are the names of all of the preferences that Photo Booth is accessing. And if you scroll through here, there's some very interesting things to see. A lot of them are preferences that Coco is checking. can see some Quartz Composer preferences here. But what's most interesting and relevant to this talk is that a lot of the preferences you can see are hidden debugging preferences, like I was saying you should have in your app. For example, enable debug menu is a preference that it's checking. If that preference is set to true, you'll get a debug menu in Photo Booth. 50% of them are hidden debug flags, just like I told you on the first slide. You should have these things in your program. Apple does. They're all over the place. And when a problem happens in development, they just turn them on. There are debug flags in there for every purpose. Disable that, turn off that, go back to the snow leopard behavior, turn off animations, it's all in there. And because this is so easy, have you guys ever heard of anti-debugging? Now, there's a flag to ptrace called deny attach. And if you call this with deny attach, anybody who tries to debug your app will just crash. Apple does this in iTunes. Apparently they consider the DRM code in there too precious to let you debug through. I don't know. If you try to attach your debugger to iTunes, it just exits, because iTunes is calling ptrace with this flag. They did this to prevent just what I showed you in Photo. The ability to just attach and set breakpoints. Now, can anyone think of a way to get around this? It's actually retardedly easy. I mean, you just set a breakpoint on ptrace and skip it. Yeah, it's just a really strange. You set a breakpoint on ptrace. You check the condition to see if RDI is that deny attach flag, and then you can do anything. You can either skip it. What I did here is I'm just instead of 1F, I'm going to pass in a 1, which is like a harmless command to ptrace, and then you're good. And so you just set it. It's really strange. Yeah. So RDI is the first parameter, and you're just overriding it with a different value. And that's an LLDB command there, register write RDI 1. And it's just, you can continue, and you're golden. And as soon as you get in there, you see all of the debug flags that iTunes has, and things like that. So, hope that really confused everybody. Reverse engineering is my thing. It takes persistence, perseverance, determination. It's about persistence, basically. I mean, you're going to be there for a long time, searching for that holy grail. And once you find it, you know, the feeling is great, but once you're, these are just clips from testing of our app, of our recording apps. I have about 10,000 of them. It's really funny to go through because I'm like, in all of them, in different shirts, every single one. Yeah, basically, it can be really rewarding, but it can also be really tiring. So to recap, build debugging in, build logging in, use the features that are there for you in the interactive debugger, but also don't forget about instruments, and also use the power of use the force of reverse engineering that is there for you. Don't be afraid to look in and see how other people are doing what they're doing. So thank you very much. Again, I'm from eCam, and you can ask me questions now, or you can ask me questions later. I love answering questions. And thank you very much.
We actually have time for one question. Yeah.
Nice. If you wanted to, if you were told again, if you wanted to learn a little bit of assembly, now time, where would you start?
Where would you start?
Yes, if you do math.
I would write a really simple program. Just build a project that just adds some numbers together and prints them out. And then look at the disassembly of it. And you would do that with OTool, and that will just give it some flags and it will dump out the assembly. And then you just go through and look at it, basically. Because it's really, once you realize what's going on, it's really not that complicated, and it really does change your view of coding when you know under the hood what's going on. When you really realize that this is all getting turned into ones and zeros and getting run through the processor, and it's just a bunch of numbers in the end. It changes your feeling about what the processor's doing. And I think it really improves your coding if you know a little bit about what's going on behind the scenes. And it certainly helps you interpret crash reports and get ideas about unusual bugs when you have an idea of what that assembly means.
It's a very good conclusion. Once again, it just ended like it started when I presented it. It's only a lot. It's that easy. So Go guys debug that easy, and it totally reminds me of the very first talk from Mike that as soon as you understand that you can mold those stuff, like whatever that was PS5, PS6, I always feel like I'm watching PlayStation. Alright, thank you guys. Now it's your time to go over this door and grab some lunch. Yeah, so enjoy the meal, and we'll be back in about an hour. That's the way to do it, Ken.
I did.
Awesome. Awesome talk. It's just too bad for me that I cannot really follow the talks, you know. It's just too busy with other stuff.
Yeah.
Was deine Dropbox auf dem Gerät?
Ja,
Okay,
aber doppelcheck. Ich zeig dir, wo das ist.
ja.
Hi.
Hey.
You are one of the guys that was suggested to me to talk about Comedia. I'm from Boings, I guess you know the other guys. Florian and Michael, I guess.
Yeah, I know those guys.
Yeah, I'm the new guy.